So this is going to be a short video about TI Portal, making a new project, and get a little overview or feel for the project. And what we need to do then is we need a CPU because we're going to work on a PLC. So let's go and have a look at TI Portal. I've already opened it. So what we have to do here now is the new project. So it suggests a name of the project. We can call this introduction, maybe. And this is where it wants to save it. How to organize your projects. What I just store them in a path like this. TI Portal data project. This is version 19, and a subfolder or something like that. You can make a comment too. We're just going to create it. Introduction. Maybe it was misspelled still. And now it takes some time for this to open. It wasn't all that bad. So let's see. We don't have anything here now. So this is the project, and you have all this add, new, and things like that. We're going to see those all over. Now you get a little more on the buttons here that you should get to know. Add new device, there's no context, ungroup devices. I don't have a lot here to do. Online access, I don't have a CPU, but you can be careful when you push on or you select things, because there can be lengthy operations. This is how I want to go online. My network adapters and how to program this. Let's see. Well, we need a new device. We want to put in a CPU here. So it's add new device. Double click. That's what I did. So I get controllers, HMI panels, a PC system that I can add for HMI and stuff. The schematic HMI can run on a PC system. And if I had installed an optional packet that's called drives, frequency converters, I would have an option down here. That's not a part of this course. Well, we need a controller. We need to call it something PLC 01. If we have more, I want 1500 controllers. What you have is 1215, and they run basically the same programs. These are legacy controllers, hard to get by anymore, but they can be programmed. An ET200 CPU, but what we want to work in is the 1500. So we are going to select a mid-range CPU of some sort. Here is the latest version with multi-core technology and stuff. We don't need that. Here you can select the firmware version. Of course, we are going to use the latest firmware here. That's pretty much what I have to do. There was information there too about the capabilities of the CPU. And now it's going to take some time again, because he wants to feed the program now just arranges the CPU and the database for the project and so on. But eventually it's going to insert the CPU. It's going to pop up over here in a while. Yes, it did in a while. Yes, and here is security settings for the CPU. Of course, you don't want any to break into your CPU. I don't care. We are working on this PLC, so there are more to do here. So you could just walk through this and get to know this stuff. Go next. Now we are just going to introduce the CPU. we are just going to push finish. Now we got the CPU here. And now we got quite a bit over here. So we're just going to walk through a little about what you can do here. This online access that we had. We can start on the bottom. You have a version control interface, add workspace. You can connect your project to GitHub. And then you can export the source files, but Simatic uses a format that calls Simatic ML, markup language. You can't read it. So it's some XML stuff. So it's not plain text that you are used to when you're programming, but you can secure your programs on GitHub, push and pop and save and whatever. Yes. Language and resources, you can set up documentation, common data, cross-device information, security settings. We can do this. We didn't do it. If you have devices here that are not in any group, then we get to the PLC. And now we can start on top. Just go through this. You have a device configuration that you can do. We're going to open that. Online diagnostic. You should try that out, but then we need a running CPU. Charts. This is something called CFC, continuous function chart, where you program graphically. Here's where you set up the charts. Here you have software units. You can have units in one CPU that you link together. The units can communicate, but when you are downloading to your PLC, it will only download one unit and not the entire program to the CPU. We are not going to look into that. Program blocks. Here we are going to do something. Technology objects, get to know it. PLC tags. This is your I/O. The tags, they are just, let's say, labels for physical I/O, inputs and outputs and so on in your PLC. The data types, PLC data types, we are going to look into that in later videos. But there's called user data types, where you can group data and give them a name, and you can structure your data. Watch and force tables. Here, a force table, then you can force in data or variables on your CPU. A watch table, you can watch variables and also change them. And they are freely, you can use them for anything. You can watch pretty much any data on the CPU has online for your program, that is. You can make a backup to your CPU. The CPU has a micro memory card. Traces. Here you can make plots, time series plots, traces. They can log data really fast as your CPU is running. OPC UA communication. This is the modern communication. There's a built-in OPC UA server in all Simatic CPUs, so they can be a server. And you don't set that up. This is the new OPC UA field exchange, where you can have OPC UA communication between CPUs and between CPUs and devices, smart sensors and so on, which is not ready yet. And the standard is probably just out. Web application, program info and so on. It's pretty much what we are going to look at here. So what we looked at in this video, we made a new project, inserted a CPU, and that was pretty much. I looked a little through what was available for the CPU.